Okay, how are you guys doing? Still got some energy left? I mean, yeah, it's Friday afternoon, so but don't worry, we're almost there. Almost time for drinks and bitterballen. But first, you're gonna have to hear me talk about XML files for about half an hour. So, XML files. What do we use them for? Well, what's their purpose? So originally, they were kind of conceived by the W3C as this sort of data interchange format for use across the internet. But nowadays, you find them pretty much all over the place. They're sort of a general data serialization format. If you've never looked at an XML file before, they kind of look like this. So you can just open them in a text editor. This is something I whipped up last week. You might think of it, you might have these apps on your phone where you have a hike and you sort of register your hike. They might save it in some XML-like format, something a bit like this. You see, okay, there's this sort of tagged structure and they're sort of nested within each other. And we see that we have some tags that open and close, and in between are more elements. And then some other elements, they just open, have some text in between, and they close again. So it has this sort of convenient nested tag structure, and if we take another look at this, we see that, okay, it's human and machine readable. Human readable, I mean, I can look at it and I can see what's inside there. I can see there's some metadata up here, a name, description, comments. I have some GPS points, so GPS point, repeat, GPS point, GPS point, GPS point. I can read it, I can edit it. That's all human readable. But also because of this structure, it's also quite easy to write functions for this, to start parsing this in your code. So we have this convenient human and machine readable format. If you know the JSON format, you can sort of compare and contrast the two. They're both for data serialization. They're both human-machine readable. They just do things slightly differently. So you can, if you want to compare and contrast the two, you don't have to. It's Friday afternoon. I can't tell you what to do, except staying here and listening to my talk. Yeah, that you have to do. So the XML file format, it's quite broad, but it's often used as the basis for other file formats. For example, SVG, so scalable vector graphics. These are just XML files. If you open one of those up, you will see that, oh, there's like circle tags and rectangles and stuff in there. It's just XML, basically. But also the Office file formats. So both the Microsoft and LibreOffice ones. So you might recall a couple of years back when we went from .doc to .docx, and from .ppt to .pptx, the X at the end, that stands for XML. You might try and open one of those docx files in a text editor, but that won't work. You will just see a whole bunch of nonsense. They just did something slightly more fancy. They're actually like zipped folders, but open it up as a zipped folder, unzip it, and you will see a whole bunch of folders, and also your assets, your images, but also a whole bunch of XML files that describe the content and structure of the file. Okay, so I could keep going on for about an hour about all these different formats that are based on XML. Let's not do that. It's Friday afternoon. But the main thing is here that you will find XML files all over the place. Even though you've never seen a .xml extension, you've probably used an XML file at some point in your life. Okay. Now that we know what they are, how do we work with them? You can start writing your own functions for this, but yeah, experience tells us that it's probably not a good idea to start doing this stuff on your own and make all the mistakes that people have made in the past. So what are sort of the standard ways of working with XML files? And the first way of working that you'll find is the document object model. That's where you're going to represent the entire file as just a tree of nodes. We can do that in Julia using, for example, EasyXML. No particular reason why I'm picking EasyXML here. It's just one of the first that I found. Was pretty simple to work with, so I just ran with it. I can read in my XML, and this will give me this document thingy, and I can get the root node out of this. Small detail here, XML documents always have one single root element from which the whole tree of elements sort of grows. This root element, I can ask, okay, what are your child elements? This will give me a vector of nodes. I can get the first one, which is this metadata node. And then I can, again, ask child elements, first one, which is the name node, and I can say, okay, what's the content? And it will print me out the text that was written in the file. So pretty straightforward, pretty easy way of working with these files. But it has some downsides. First one is you have to load the whole thing in one go. And if you have a really big XML file, not so good for memory usage. And again, not for performance. Another downside is that you have to sort of navigate through this whole tree to find the tags you really want. This can also be quite complicated if it's sort of like deeply nested structure. So another way of working with XML files is the simple API for XML, or SAX for short. That's where you're going to represent the file as actually a stream of events. You're sort of going to jump from one tag to the next, to the next, to the next, and then you will see, okay, what am I going to do with this particular tag? Let's say this hike document, I want to figure out, okay, what's like the maximum elevation that I've encountered in my hike? I can do this with easy XML again. I use the stream reader. I get this XML stream out of it. I can iterate through it until I reach the end of my file. Then I can say I want the tags with name, elevation. There's some stuff cut off here because, yeah, elevation tags, they appear twice. Once as an opening tag, once as a closing tag, and I just want to ignore the closing tags. That's just the stuff that's cut off here. Not that important here today. And from those elevation tags, I can say, give me your content, and I'll get my elevation numbers out of this, and I can see, okay, I get my numbers. What's the maximum number that I see? But not really, because these guys, they're not numbers, they're strings. So Julia will actually just tell me, like, what are you talking about? The maximum of a vector of strings. I don't know, what's that supposed to mean? So to our human eyes, these look like numbers. They're like, okay, these are numbers. We want them to behave as numbers. But Julia will say, no, these are strings. I don't know what you want me to do with those. So this is actually something that's a bit of a problem with these two approaches, is that everything is just text. Everything is just strings. And we want something more than that. We want to be able to use these things as what they really are. And that's where XML data binding comes in. That's where we're going to say, okay, we don't want strings, we want actual native objects. There's more ways of working with XML files. For completeness sake, I'm just going to mention this. But today, Friday afternoon, we're just going to work with XML data binding. So yeah, we want to do this data binding, but the XML itself is actually not enough to do this. It does not contain enough information. An XML in and of itself is actually very simple. Basically, anything that has the correctly formatted nested structure of tags, contains no illegal characters, has this one root element, it's pretty much a valid, well-formed XML, I should say. I need to get my terminology exactly right here, because valid means something very different, as you will see in a bit. So these well-formed XMLs, pretty much anything can be in there. For example, this elevation here it says 256.3 as a number, but it might as well have said 256.3 spelled out in English. There's no way of telling this by just the XML itself. So we need something more here. And that's where XML schemas come in. So XML schemas, you can think of them as containing XML type definitions. They're going to say, okay, this element is going to conform to one or the other kind of type definition. And this is what it means to be valid. If you follow a certain XML schema, you're valid according to that schema. So these file formats from before, for example, the SVG, if I take my hike example and I change the .xml into .svg, and I try to load it into Inkscape, it will say, yeah, no, this is not a valid SVG. This is just nonsense. And that's because my file is not valid according to the SVG schema. So a lot of these file types that are based on XML, they will have some schema saying, hey, this is what this actual file format is. Quite often, these schemas are given in XML schema definition documents, or XSDs for short. What do these look like? Well, here again, I have my example that I whipped up myself last week from my hike, and the first thing we see, hey, it's an XML again. So this whole XML schema business is sort of this cute self-constructing, self-describing thing, XMLs describing XMLs. Computer scientists seem to love this a lot. I think it's pretty cute that you can do that. So yeah, let's take a quick look. Well, what's in this thing? So we can see all the way at the top, it says, okay, I'm a schema, fine. Then it says element, hike type. Okay, this is going to be our root element. So it's already saying like there's got to be this one element there, hike, and this is going to conform to this hike type. Hike type, what's that? Oh, it's a complex type. This will say, okay, there's going to be some elements underneath this. It's not going to contain the direct content. Which elements? Oh, metadata GPS points. So that's the very first thing we see here. It will describe these names should be there. These tags have to be there in order to be valid. Next thing we see, there's some types over here. It's going to say metadata is of this type. GPS points is of this type. And if you think about it, this is basically like a struct definition in Julia. You have a field name, you have a field type. So this maps pretty nicely. What else do we have here? Yeah, we can take a look at metadata type. Okay, It has a name, a string. Again, so in Julia, this would be name and then type string. We have description type. Aha, a simple type. So a simple type is the one that is just going to contain some content here. And we see it's a restriction of just a string. And it's going to have a maximum length of 256 characters. So this is also another one very common thing you see in schemas. You will get these restrictions where you're saying, oh yeah, it has a certain maximum length, minimum value, maximum value. There's tons of these things. The XSD specification is really long, really complicated. Again, Friday afternoon, we're not going to go through all of them. But the upshot is that it's going to have some restrictions saying this is what stuff that can be there, this is stuff that can't be there. What else do we have? Comments is a string, but now the min occurs is 0, meaning that this thing might be there or might not be there. And if you have some code, you should handle this in a sort of a good way. Julia has a pretty good way of handling this. Just do a union, string, comma, nothing, default, nothing. Well, that's a nice way of handling this. So yeah, we have optionals. Some more stuff. Let's see, what else do we got? GPS point type. GPS point. Max occurs unbounded. Aha. So now we know this thing can occur many times, as we saw in the initial example. We had 3 of them there, if I recall correctly. In Julia, this would probably naturally map into a vector, which is going to repeat it as many times as we want. And GPS point type itself, here we see elevation is decimal. So now we have the information to actually say, hey, these strings, we should probably parse them into some number type. OK, so we have our schema. This describes what should be there, and this describes what a valid file is. What can we do with it? Well, naively, you might first say, OK, I can sort of consider this as a piece of documentation. I can start writing my own types and functions for this. You could do that, but you'll probably spend quite a lot of time on this. And if you spend a lot of time on this, and then somebody comes along and says, like, hey, I have a new version of this schema. OK, damn, I have to do all this work again. That's why people in other languages, Java, C#, C++, among others, they said, OK, let's make you some utility that takes the schema definition and then generates class definitions out of this. And this works really well, because then you can say, OK, it maps pretty straightforwardly onto class definitions. I get all this code for free, and I can start writing some functions for these classes. The same thing didn't exist for Julia about 2 years ago. But it does now, because I sort of started creating this thing. So I made this sort of small constellation, I would say, of 4 packages. XSD to struct, abstract XSD types, XML struct loader, and XML struct writer. And I sort of grouped them together on this sort of XML struct tools, because what they do is, they will start treating these XMLs using Julia structs, hence the name. So how do they all sort of fit together? How does it all work? I'm going to explain this by using some example here, quite literally, example.xsd, example.xml. So you have these things. What should I do first? First step here is to feed in the XSD into my XSD to struct. What will pop out is some Julia code, which will be a module. And this will contain all these structs and types from my XSD. All right, that's nifty. But it goes a bit further than that. It also depends on this other package called abstract XSD types. And this is where things start to get interesting. Because in my types, I have things where I say, like, OK, this should behave a bit like a string. This should behave a bit like a float or like an integer or stuff like that. And that's why I made these abstract XSD integer, abstract XSD float, and abstract XSD string things in abstract XSD types, hence the name. And also added all the needed functions there to make them behave as the thing we expect them to behave. I want these elevation numbers to behave like numbers. I want to be able to say, like, hey, give me the maximum of those. So that's why I added all this sort of utility functions into the abstract XSD types. There's some other stuff in there, things like promotion rules, some more utility functions, conversion things. There's a whole bunch of stuff there. You can check it out later in the documentation of that package. In practice, what does it look like? I call my XSD struct module function on my XSD file, and it says, hey, I spit out this example.gl file. I can then just include it, and it says, hey, now I have this hike module. There's no coincidence that it says the hike module. The XSD will say, like, hey, I will start putting my stuff into this namespace, and that the name of that namespace, well, that's going to be the name of my module here. All right. So now I have this module containing all these types and constructors. What can I do with it? Well, first thing I want to do with it, I want to load in my XML. So I'm going to load in my XML. I feed in my XML into XML struct loader, and I also pass along this module. And what it will do, it will first load in my XML using just some box standard way of loading XMLs, and it will start walking through it and then says, OK, I have some data here, feed it into the constructor. Some data there, feed it into constructor. And what pops out in the end will be a variable that will conform to this type of the root node. So I have this completely typed out variable that represents my document. Practice, it looks a bit like this. I have here load example.xml. I need to pass along this module to it, because otherwise it doesn't know, OK, where do I need to get these type definitions from? And it spits out a variable over here. And in here we see, yeah, we have the metadata, we have the GPS point. There's some other stuff over here. It's Friday afternoon, not want to talk about it here today. And I can do again, like I did with the document object model. I can say hike.metadata.name, and I get the same string again. OK. But this is not really impressive part, because this is the part we already had before. We already had strings. Now I want to do something more impressive. I can also use these types in my own code. I can start writing functions for them. For example, I want to do this get max elevation thing. For example, I can do it in this way. I can say get max elevation for a hike. That's what I want. For a hike type, that's just getting max elevation of the GPS points in there. And then get max elevation for the GPS points type. Well, I get my GPS point from the GPS points. This looks a bit funky. That just has to do with the fact how these XSDs are written. If you recall from the previous slide, I had GPS points type, which had one element of GPS point type with max occurs unbounded. So it actually will contain a vector of GPS point type, but the field is called GPS point. That's just kind of how these XSDs are written, and I kind of just copy the name. That's why it looks a bit funky. So this thing over here is a vector of GPS point type, I should say. And then elevation, this elevation function for your GPS point type is just getting the field elevation. Using the dot here, one of the really nice things of Julia, I just broadcast it across the vector immediately. And I go from a vector of GPS point type to just a vector of floats, basically. I can get my maximum out of this and return it. OK, nice. And just to show that it works, I can call get max elevation on my hike. Here, there's my maximum elevation. Nice. So now I can start using all this dispatching functionality that's so good about Julia and start writing some really complex functions with this. But I can go even further. I can start editing this variable. I can say, like, hey, I want to add some more GPS points to it, or I want to sort of rewrite the comments or something like that. Or I can just make something from scratch. I can just start calling the constructors, start filling stuff in. And then, OK, the final step here, no big surprise, I don't write this out. For that, I use XML struct writer. So I can feed in these guys over there, and it will write out well-formed and valid XMLs for me. So that's pretty neat. And now if my colleague comes over and says, like, hey, I have this new version of the XSD, I can just plug it in over here. A whole bunch of this machinery will just happen automatically. It's only this bit here that I might have to update. Depends a bit on how exactly he changed the XSD. Maybe with some luck, I don't have to do anything, because it's just made in a compatible way. All right. So what will be the future of this thing? Because if you might have already looked through the registry for this thing, you will not find it. That's due to the fact, I'm an employee of Siux Technologies. I was working for ASML as an assignment, and that's when I made this thing. So currently it's still over there, but we're going through all the red tape to get it open sourced. So don't worry, it'll be there soon. It's, by the way, not the first thing from ASML to be open sourced, because some colleagues over there, they had sort of a very similar situation with writing PPTX files. Didn't really exist, so they just made it themselves and then said, like, hey, we can open source this, and they did, so now it's out there. And you can write PPTX files from Julia. All right. Once it's open sourced, I must say, it could use some contributions here. The XSD specification is very long, very complicated, so I just took a very pragmatic approach here. I just looked at, OK, what is the stuff that I need? What is the stuff that I need to work? And I just started implementing that and just left it at that, more or less. So there's still a lot of stuff to do there, but also, yeah, some optimizations could be nice. Again, I took a very pragmatic approach. As soon as what I needed worked, I sort of, yeah, stopped with it and moved on. But yeah, I think we can do some optimizations here, because I think it's very important that we get this absolutely right. Reason being, this could save us a lot of time to actually do the cool stuff. We want to do the algorithm development. We want to do the scientific computing, the data science, all this kind of cool stuff. But if we have to start writing our own file parsers to do it, and yeah, just knit it, we need some data from somewhere, we need to get some files. Yeah, it's like you're in the forest. It's like, oh, how do I do this, and how to move through this tree, and then parse this thing as that. Oh, but now I have to deal with this optional, blah, 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 blah. So you're kind of lost, you don't really know your way, and it's going to take a lot of effort to hack your way through it. But if we get this really right, yeah, you might have to still write a few functions here and there, but somebody already cleared a path. It's like, okay, I can see I have to go in that direction, just walk across the path, and I'm kind of done. But it's not only important for us, it's also important for other people. Because other people, let's say some C++ developer, he might have this really fancy code base, say like, for my computational algorithms, I want to move over to Julia. But, man, I have all these XML files and I have my XSDs, and in C++ this is kind of solved. I don't want to go to Julia and have to cut my way through the forest there, do all this tedious stuff before I can actually do the stuff I want to do. But if this thing works really well, we can say, hey, no problem, it's already solved. Just come on over, join the club. So if we get this really right, it's more time for us to do the cool stuff, and it's easier for us to get more people on board with Julia. All right, thank you.
I think we actually have quite some time for questions, if there are any. Yeah, I'll come right.
Thank you for the wonderful package. I actually looked during the presentation because I want to use this right now. like 3 weeks ago, I hand wrote some XML parsing stuff, and I hated it. So please, I want this package. I need it.
Thank you. Oh, yeah.
Yeah. Start writing emails to the people at ASML. Start a petition.
So I know it's Friday afternoon, but could you elaborate a bit on how you handle attributes?
Yes. So attributes, it's one of those things that I sort of kind of glossed over a bit. I have to go all the way back. Well, yeah, here. Basically, I have this sort of extra field here where I keep a dict with the attributes. Took a very pragmatic approach, just put them over there. I guess you can do something more intelligent there, but for now, I just put it over there, because they weren't that important for me yet.
So when designing an XML file schema, it's sort of arbitrary if you add like child nodes for something or put attributes. So it would also be good to be able to map attributes to struct fields, but yeah, that's currently not implementing yourself.
Yeah, currently not really, because for me the attributes weren't that important, because I said, yeah, took a very pragmatic approach here. Yeah.
Can I quickly, do the attributes have any type?
I have to think for a moment. I think not really in the cases that we were looking at.
Okay.
Yeah.
Any more questions? I see Max is ready to throw the...
Yeah, hi, thanks for the nice talk and for this nice tool when it will be open source. But it's almost a joke question. Have you benchmarked it against Python, JavaScript, and C++ XML parsers? It's almost a joke question.
Yeah, so very interesting question. For us, mostly, if I go a bit forward, so for us, the writing part, that's kind of fine. The loading could be done a lot better. We're still working on that one. So if you were to benchmark it with those guys, it will probably come out worse. I'm almost certain of that. But we're working on it.
Any more questions? I see a hand raised.
Are there already XML loading packages out there in Julia, which might do the loading, and you could combine it with the validation?
Yeah, so I kind of briefly mentioned this. So XML struct loader, if we go back in the other direction, You see it actually says here, loading with EasyXML. So I already use EasyXML to load it first as just an XML. And then I add my extra stuff on top of that. I'm actually thinking of maybe making it a bit more flexible, that you can sort of slot in whatever XML library you want, but currently it's sort of hard-coded to EasyXML. But yeah.
Another question?
Thanks for the presentation. Absolutely agree with your last point that we should basically pave the way for others with these basic packages. I think relating to the previous question, I think there's also from Julia Hub actually XML.jl that should provide a native experience, hopefully, for loading. It doesn't do XSD, so well, good on you for tackling that. Do you use struct types in this package? Because it relates very much to the JSON approach.
Yeah. So struct types, I've thought about using them, but in the end, I decided to not do it right now, basically. So I might start adding this on later, but currently it doesn't use it.
Fair enough.
Any more questions from the audience? Oh, we have one at the front. I might be quicker.
Hi, just a simple question. You mentioned that this specification is like really big. Can you give me an example of something that that the current package is missing? Like, why is it so big?
Okay, so I don't know why the specification is so big. Probably they want to cover a lot of bases. Yeah, so there's a lot of constructions in there. I didn't mention those at all today. You have things like groups, you have things like choice, you have things like a whole bunch more restrictions. You have date-time types in there. There's a whole bunch of stuff in there because it kind of needs to capture every possible thing.
I see.
You can look it up. It's just look for W3C XSD specification or something like that, and you will see it's a non-trivial document.
Thank you.
It actually makes me wonder. So you mentioned XSD is an XML file. Mm-hmm. Is there an XSD for the XML file that specifies the XSD?
It says somewhere up top. Yeah, here. So the XML, so the XSD namespace is defined over there.
Yeah, but is there an XSD schema?
It's not
for
an
the
XSD.
XML that's...
So it's not an XSD, but it is a schema, just in a slightly older file format. Actually, XSD has replaced an older way of doing XML schemas, and that one is still written in the older way.
Okay, so there you go, full inception.
So there is a schema for schemas.
Okay. But quickly, before we get lost in levels, let's thank Tom again.